So before we get started, I'm about to tell you it's about to go down. All the way down. Difference of squares gone wild. It's about to go down, y'all. It's really about to go down. You won't see one like this. But I'm telling y'all, we're going to be factoring for a little bit and we're going to be asking ourselves, is this the difference of squares? And then you'll see. So let's look at this problem. So we have x to the eighth power minus 256. Well, technically, what gives you x to the eighth power? This is a perfect square because x to the fourth, you don't have to write this time, times x to the fourth. Yeah, we're in the ocean today. That's what we in the ocean is x to the eighth. All right. So I can break this down. This is the difference of square. X plus 4, x to the fourth plus 16 times x to the fourth minus 16. Well, this is another perfect square. This is the difference of squares. It's the difference of x squared plus 4 times x squared minus 4. But wait, there's more. Oh my gosh. X squared minus 4 is the difference of x and 4. X and 2, sorry. And so we now have to factor that into this. So this term came from right here. This term came in right there. And then we factored this term into these. Difference of squares gone wild. All right, so yeah, we're gonna do something like that. Yeah, that's what we're about to do. So let's go back to the basics, because I see some of y'all about to lose y'all mind. But it's not gonna be that hard, because all you gotta ask yourself, is this the difference of squares? And when you ask yourself that, you'll be fine. So last year, this was, it says, in order to use this rule, both A and B are squared numbers, or squared terms, because they're not always numbers. You can note, you cannot, that's what it says, Mr. O'Neill, you cannot use this if there is an addition sign between A and B. Now, Zach and Ty, I don't know if y'all know Zach and Ty. It was Ty Hamilton. I cannot think of Zach's last name. Well, yeah, whatever. This year, let me see, who do I replace? I'll replace this with Ahmad. Last year was 2 boys. This year is going to be a boy and a girl. It's going to keep it in the family. Ahmad and get somebody from third block. Nicole. Yeah. Okay. All right. Ahmad and Nicole. That's why it's called difference of squares. So if it's not the difference, meaning a subtraction sign, y'all see that? Y'all see that? A subtraction sign, you can't use this shortcut rule. Ahmad, Nicole, you got that? We're in the ocean. Don't drown. Don't drown. Okay, if a polynomial cannot be factored, then it's prime. Okay, that means you can't take out a GCF. You can't do anything with it. All right, the GCF is 1 and whatever it is. All right, it's like a prime number. A prime number such as 3 has the factors of 1 and 3, 1 times itself. So a prime polynomial, prime binomial, prime anything, has the factor of 1 in itself. All right, so the first thing we ask ourselves, can we find a GCF between 16h squared and minus 9h squared? No. Is this the difference of squares? Well, yes, it is, because 16 is 4 squared, h is h squared is h squared, 9 is 3 squared, and a squared is a squared. So this is the difference of squares. So we end up getting 4h plus, again, order doesn't matter. I just do addition first because it's whatever. 3a, and then 4h minus 3a. Do y'all like the ocean? I'm not feeling the ocean. Y'all know my favorite. It's lava. Let's go to lava. Lava's the business. All right. Okay. Can we factor this anymore? Well, there's nothing else going there. This is not a difference of squares because h and a have to be squared. All right. So, we're done. We are done. D-O-N-E. Done. All right, so I see 21 minus 4b squared. All right, this is a binomial. We're subtracting. Is this the difference of squares? We're going to speed that up in this video. 121 is 11 squared, 4 is 2 squared, and b squared is b squared. So yes, it's a difference of square. It is the difference of 11 minus 2b times 11 plus 2b. All right. Is this the difference of squares? No, it's not. So we're done. D-O-N-E. All right, we're done. We don't have to do anything else. Okay, 27g cubed minus 3g. Can we factor out a GCF? Can we factor out a GCF? Did I ask that in this question? I'm sorry, y'all. I keep failing you. Sorry. Can we factor out a GCF? Yes, we can. What's the GCF? We can bring a 3g right out of this bad boy. Come on out of there. And they're hiding. Get out of there. Get out of there. So when we bring out a 3g, JL just left, y'all. When you bring out a 3g, you get a 9g squared minus 1. Well, I'm subtracting two binomials, and one of these is squared, so we need to ask, is this the difference of squares? So 9 is 3 squared, g squared is g squared, and 1 is 1 squared. Well, we got to keep factoring. We are not D-O-N-E. So we end up with a 3g on the outside, and this is the difference of 3g plus 1 and 3g minus 1. Is this the difference, y'all? And we don't have to waste our time. Clearly, the variable has to be squared in order for it to be a difference of squares. D-O-N-E. Y'all like that, don't you? D-O-N-E. All right, so let's look here. Do we have a GCF? GCF. Y'all, we got to ask ourselves all the time, Mr. O'Neill. And y'all need to catch me. Everybody who catches me and without asking the first thing, did I say a GCF, raise your hand and you'll get a white ticket. Because that's how important this is. All right. Every time I forget to ask that, you will get a white ticket. Not in the video. In person, y'all. In person. Come on now. Get your life together. Latrell just got happy. All right. So GCF 9 and 36. Yes, there is a GCF. Get out of that 9 in there hiding. In there hiding in that 9 and that 30. You get out of there. Get out of there. So we end up with b squared plus 4. Ahmad and Nicole. Look, watch this. Ahmad and Nicole. Hey, how are you? Great to see you. All right. Is this the difference of squares? Well, I hear Ahmad saying, no, Mr. O'Neill, because it's not a subtraction sign. And Nicole's like, I don't think it is because it's not a subtraction. You know, Nicole can be feisty. So that's Nicole and Ahmad. That's my impression. It's not the difference of squares. Did we factor? Yes, we did. So is this prime? No. We are D-O-N-E. Y'all got so much energy today. Church was really good. Might be why I'm feeling so good. All right. 3a squared minus 20. 3a squared minus 20. Well, I see a square here. I'm just saying. All right. So can we factor out a GCF? I asked myself. I caught myself. Ha! No. Can we factor out anything else? No. Is this the difference of square? Well, 3 is clearly not a perfect square and 20 not a perfect square. What do we end up having? P-R-I-M-E. It's prime. Can't factor you. We're done with you. All right, now let's get to difference of squares gone wild. All right, so I'm gonna warn y'all about these 4s. We already saw anything to the 4th power is a perfect square. It's a perfect square of a something squared times something squared. That's what it is, because 2 times something squared, exponents multiplied, we add them, keep the base and add the exponent. So anytime we see these 4s, you already know it's a perfect square. So I'm just getting y'all a hint, just setting your life up. Anytime you see anything raised to the 4th power, you know it's a perfect square. You know, because when y'all do them on your own with your little partners, because I'm gonna be done with y'all. I'm done. All right, so I think my lava got to lose a little weight, so we're gonna shrink you down, put you on a diet. Come on down one. Come on down a notch, buddy, because we're going to need some room. Little room. Okay, b to the 4th. We know this is a perfect square. 16 is a perfect square. So it's the difference of b squared minus 4 and b squared plus 4. You know what just came to my mind? You know, as you teach, you evolve. Let's always put the minus sign first. So we can always refer to that one and ask, is this the difference of squares? Let's just make that a rule. Let's just make that a rule, you know, so we can always ask in the beginning, is this the difference of squares? So let's just always put the minus sign, subtraction sign first. No, it doesn't matter in reality, but in our state of thinking, let's put it first. So is this the difference of squares? Well, b squared is b squared. 4 is 2 squared. It is the difference of squares. So do we have to factor more? Yes, we do. If you finish, stop here and say D-O-N-E, you're W-R-O-N-G. Okay, so this is the difference of b minus 4 times b plus 4 times b squared plus 4. Y'all see why Lava had to lose a little weight? You wouldn't be able to fit up in here, buddy. Not like that. Had to shrink you down a little bit. Okay, so is this the difference of squares? No, y'all. No. You know why it's not? Because b had to be squared. We're D-O-N-E. That's what we are. All right. Let's keep it moving. You know, if you need to go back and watch the video, just go back and rewind. If you don't get it, go back and rewind it. I said everything I need to say concerning that. Go rewind it to make sure you understand it. Okay, so 4a to the 4th minus b to the 4th. We know that this is a perfect square. I told y'all. This is a perfect square. I told y'all. This is a perfect. It's the difference of squares. So it's the difference of 2a squared minus b squared times 2a squared plus b squared. Okay? Again, we can take the square root of this, take the square root of that, and we end up with 2a squared, and we end up with b squared. Is this a difference of square? Well, 2 is not a perfect square. So it's not the difference of square. Well, a squared and b squared are, but it has to be together. 2a squared is not the difference of squares, so we are D-O-N-E. All right, what do we see here? Well, I see 4 terms. And when I see 4 terms, I know that I need to factor by grouping. Okay? So we end up taking a r squared out of here, and I end up with r plus 6. And we want this to be r plus 6, so we need to take out an 11, a positive 11. So we get r plus 6. So we end up with r squared plus 11 times r plus 6. Is this, Nicole Ahmad, is this the difference of squares? No, it's not even a square. 11 is not a perfect square, and it's not the difference. So are we done here? Yes, we are. We are D-O-N-E. We're not playing games today. We're not playing games. We're getting the job done. We're not playing games. Okay. All right, let's move on. Y to the 4th minus 1. Well, I know this is a perfect square. And I know 1 is a perfect square. Is this the difference of squares? Well, sure it is. It's the difference of y squared minus 1 times y squared plus 1. Hold up. I see y being squared. Is this a perfect square? Both of these are. Is this the difference of squares? Well, sure it is. It's the difference of y minus 1 times y plus 1 times y squared plus 1. Okay? This, Sydney, breaks down to this. This is already here. We keep the term that we factor. These are all the factors. So if I multiply this times this, I will end up getting this. And if I multiply these out, I end up getting this. Why? Because our outer, and inner terms cancel. Okay? Our outer and inner terms will cancel. Outer, inner, gone. We'll be left with y to the 4th minus 1. All right, we're D-O-N-E. Okay, let's look at the next one. All right. So I know I'm factoring by grouping. I know that. And so I take out a 7x squared. Bring that out of there, and they're hiding. Get out of there. You get out of there. Okay? Something's wrong with your teacher. Okay, we end up with x plus 3. Lord, I hope I don't mess up. Try to talk about something. You get out of there. All right, so now I want this to be x plus 3. So in order for that to happen, I need to take out a negative 7 and I end up with x plus 3. And so now when I do this, oh, y'all, what did I forget to do in the very beginning? You're about to find out in a second. I didn't ask what, is there a GCF? And this is the first time there's a GCF between all these terms, but whatever. We're going to, I haven't been asking that the whole time, have I? Nope, all right. Okay, so, yeah, I'm kind of horrible at asking that question. That's why I'm gonna give y'all extra credit, because I keep forgetting to ask that question. All right, so so what we find out is that when we put these two terms together, 7x squared minus 7 times x plus 3, what did we discover? We're about to discover a whole lot, y'all, because this problem is the hardest problem. It's not hard, but it's the problem that most people make mistakes on. There is a greatest common factor here, and the greatest common factor is 7. I'm gonna redo this problem as well, the other way, the correct way, so y'all can pick the correct way to do it as well. There's the greatest common factor of 7 here. So, and that will leave me with x squared minus 1 times x plus 3. Y'all, I see something squared, and I see the difference. Is this the difference of squares? Yes, it is. It is the difference of 7 times x plus, we said we write the subtraction sign first, Mr. O'Neill. That's what we said. X minus 1 times, that's an ugly one, but it'll live. X plus 1 times x plus 3. Y'all, that's the difference of squares gone wild, for real, for real. All right, so I'm going to redo this problem, factor out a GCF in the beginning. All right, come on. Delete. Come on. Erase. All right, so if I look here and I take out a GCF early, I can take out a 7, right? Because everything has a 7 in common. So I'm left with x cubed plus 3x squared minus x minus 3, right? And so I'm still factoring by grouping. So I have the 7 on the outside. I'll take out an x squared. Y'all might want to do that or whatever. The brackets just to show, you know, a different set of parentheses. So I take out an x squared and I get an x plus 3, and I take out a negative 1 and I'll get an x plus 3, right? Right. Y'all with me? Okay, close my little bracket. And now I bring these two terms together, so I end up having 7 times, I can take the brackets off because I'm now making parentheses, x squared minus 1 times x plus 3. Y'all with me? You with me? This is this and this, factored by grouping. And then I ask, hold up, I'm subtracting. Is this the difference of squares? Yes, it is. And we get x minus 1 times x plus 1. Please, y'all, don't forget about this term. Y'all don't be mean. Don't forget about that. All of this is the answer. This whole thing is the answer. That's my favorite one. It's just so beautiful. That's beautiful math there. Whew, I just love it. Okay, factor by grouping. GCF. Nope, buddy, not today. So we end up taking a m squared out, and we end up getting 2m plus 1. I want this to be 2m plus 1. So I need to take out a negative 25 and end up being 2m plus 1. All right, and now I bring my terms together. I get a m squared minus 25 times 2m plus 1. Oh, hold it. What do I see? I see a m squared minus, is this the difference of squares? Well, it is. It is m plus, we said, Mr. O'Neill, we changed our life today. We changed our life. M minus 5 times m plus 5 times 2m plus 1. Because we can't forget about you. We can't. I forgot to write D-O-N-E. And now is, no, you're not. I mean, you're going to ask that. That'll be simple little question. We are now D-O-N-E. All right, we got 2 more problems and the rest, no, 2 more. I'm not going to do that one for y'all. I don't know if I'm going to do it. I might leave it to y'all because I'm about done. The video's almost 20 minutes and y'all had to watch another 10 minutes. I think we're done. We're going to be done after this problem. Y'all seen enough. All right, so 5x squared minus 9. Well, GCF, nope, can't take anything out. X squared minus 5 is not a perfect square. I can't factor this. This is prime. That means we're done. Okay. Can't do anything with it. GCF, this bad boy. Come on, take out that 3, hide in there. You get out of there. You get out of there. Hold up. Is this the difference of squares? Well, it is. It's the difference of x minus 1 times x plus 1. Are we done? Yes, we are done. And this last one, I'm done, y'all. I'm done. I got to make 2 more videos. And yeah, I'm done. Y'all got the rest. You're going to work together. Some of these are easy. Anything to really watch out for? Not really, because I've done everything for y'all. I even tell y'all the little tricks about the 4s, and I told y'all the GCF stuff. Make sure it comes out of there. Y'all should have room underneath there. I think I did a great job, other than the little simple mistakes I made. Mr. O'Neill's gonna make a mistake, but it don't make me any less great. Oh, and that rhymes. Oh, I'm feeling myself in time. Oh, I should quit teaching and start MCing and whatever. I just messed up my rhyme. Anyway, y'all have a great life. Treat Mr. Chandler with the utmost mistake. Oh my God, my words. Utmost respect is what I was gonna say. Anyway, have a great life.